The last that we're going to talk about is a true experimental design. So this is the strongest that we have. It includes steps to ensure experimental and control groups are equivalent. Experimental and control groups are tested at equivalent time intervals. This is to reduce threats to internal validity arising from factors such as maturation, regression. Randomization and matching is used. We have randomized controlled trials, considered to provide the strongest and most credible evidence of any research study. Randomized controlled trials. Randomized pretest, post-test, control group design. That's our classic experimental design. Randomized pretest, post-test, control group design. A mixed design. Two groups are formed by randomly assigning half to the experimental group and half to the control group. Both groups are pre-tested and post-tested in the same manner and at the same time. Factors that could jeopardize internal validity are controlled. We have randomly assigned an intermittent treatment group, a deferred treatment group, and observations and measurements of the variables. So again, we have two groups happening here. The subjects are randomized. In the bottom example, the subjects are matched on extraneous variables. Observation, treatment, observation. We could talk about a multivalent experiment. Do you remember that? Assembling groups that receive different values or different amounts of the experimental treatment. You're able to demonstrate a change in the dependent variable as a function of the amount of the independent variable. So in this example, we have 4 groups. They're all random. There are 1 independent variable, but 3 values of it, x1, x2, x3. And then we also have a control group. And again, we're looking at within subjects and between subjects. So it's a mixed method. Parametric, this is even stronger. 2 types of the independent variable. And to make things even more complicated, with varying amounts of each type. So we have the x, I think that says missed 1. So, and then the x distributed. So we have 2 independent variables. Within those 2 independent variables, we have 3 levels of each. We also have, again, at control, the subjects are randomly assigned, pre-test, treatment, post-test, within subject design, and between subject design. Replication, that helps to strengthen external validity. In one example, we have an initial experiment done on adults, and then we have the exact same study replicated in children. So that helps strengthen our external validity. The results we found in adults, we can replicate in children. So the treatment can be used on both adults and children. The Solomon randomized 4-group design also has strong internal validity. It controls for the interaction between pre-testing and experimental treatment. So let's look at this. 4 groups, all randomly assigned. The first group, observation, treatment, observation. The second group, a pre-test and a post-test. Third group, treatment, post-test. Fourth group, just a test at the end. So basically, like, every variable is controlled for.